Hi, welcome back to TimeCode channel. I'm Jaegu Wong. Today we are going to discuss the SBP trial paper 2. Let's start. For section A, question number 1. Diagram 1.1 shows the process involved in the preparation of the nitric acid in the industry through the Oswald process and preparation of fertilizer from ammonia. Okay, so if we look into the diagrams here, okay, nitrogen react with hydrogen, undergoes a process X to produce ammonia. So here we will know this process actually is called Haber process. So in the Haber process, it will produce ammonia gas. The ammonia will undergoes a Oswald process to produce the nitric acid. The ammonia react with the sulfuric acid, then produce a fertilizer. Okay, fertilizer. So here, okay, we can put in some information about the condition in the process. Okay, so let's say in the Haber process, the temperature involved is 450 to 550 degrees Celsius. Then the pressure is 200 atmospheric pressure, and then the iron as the catalyst. Okay. Then in the Oswald process, okay, the catalyst used is platinum. Okay. Then the pressure is 4 to 10 atmospheric pressure, and then the temperature is roughly 600 degrees Celsius. Okay. So now let's look into the question here. So the process X is called the Haber process. Okay, Haber process. Then fertilizer A. Okay, let's look into the fertilizer A. Is ammonia react with the sulfuric acid. So ammonia, if react with sulfuric acid, so it will produce the ammonium sulfate. Okay, so some ammonium sulfate is the fertilizer. Fertilizer. So fertilizer is called ammonium sulfate. Okay. Here is the state you can write in formula, or you can write in the name ammonium sulfate. Okay, then the catalyst P, under this catalyst P will be platinum. Okay, so 3 marks here. Now next question. Diagram shows the cookware made from the glass. Okay, so just a revision. There are 4 types of glasses here. Okay, number 1 is called borosilicate glass, 2 soda lime glass, and then fused glass, and then finally is the lead glass. There are 4 types of glasses in the SPM syllabus. So here, okay, for the cookware, okay, for the cookware is a borosilicate glass. Okay, borosilicate glass. So what is the properties of this type of glass? So if used to make the cookware, okay, very logic, it can withstand a very high temperature, withstand temperature. Okay, actually it has another 2 more property. Okay, there is, it can chemical durable. Okay, then another one will be low thermal expansion. Okay, so any one of these answer can be accepted. Okay, C. Diagram 1.3 shows the dialogue between Mrs. Fazila and her daughter Umu. He just finished baking a cake. Okay, let's see the conversation. Mom, look at the cake that I have baked. Okay, the texture of the cake is not smooth. Okay, texture not smooth. Okay, and then less attractive. Okay, so there are two problems here. The texture is not smooth. Another one is it is less attractive. Okay, so based on the dialogue, suggest 2 food additives to improve the appearance of the cake and state the function in the step table 1. So there are 2 food additives can be added into the cake to improve the texture and then make it more attractive. Okay, so to make it more attractive, we can put in coloring. Okay, coloring. So the function of the coloring is make the food look more attractive. Okay, so another one is to make the texture of the food become smoother. Okay, so actually that one is under stabilizer. So stabilizer is improve the texture of food. Okay, by improving the consistency of food. Okay, question number 2. Diagram shows the apparatus to determine the melting point of naphthalene. Okay, C10H8. Okay, it was heated from 60 to 90 degrees Celsius. The changes of the temperature of the naphthalene were recorded every 30 seconds intervals. Okay, so we can see this is the X. So normally if naphthalene the melting point is around 78 to 80 degrees Celsius. So X normally you put it into the water bath. Okay, then put inside the boiling tube and then we can heat it directly. And then the boiling tube cannot touch the bottom of the boiling of the beaker here. Okay, so next we look into, so number 1, what is the X? Okay, what is X? It will be water bath. Okay, so what happens to the temperature of the naphthalene when it is melting? So when it is melting, okay, the temperature remains unchanged. Okay, no change in the temperature. Okay, why the temperature remain unchanged during the melting point? Okay, so 2 marks. There are 2 points you need to write for this answer. Okay, number 1, the heat energy absorbed. Okay, so it's used to overcome the force of attraction. Okay, force of attraction between between the particles, right? So here is naphthalene. So we know the particles here will be molecules. Okay. So between the molecule of naphthalene, so that the solid can change to liquid. Okay, so 2 marks here. So next question, let's see. The experiment was repeated by replacing the naphthalene with the solid ammonium nitrate. So given here ammonium nitrate, it has the melting point of 169.6 degrees Celsius. So after being heated for a few minutes, the solid nitrate is not melting. Okay, not melting here because we are just now using the water bath. Okay, so water bath, the boiling point for the water bath is 100 degrees Celsius. So the maximum temperature can be reached will be 100 degrees Celsius only. So for the ammonium nitrate, the melting point is 169 degrees Celsius. So water is not able to melt the ammonium nitrate. Okay, so we have to find another alternative. Okay, so number 1, what is the type of particles in ammonium nitrate? Okay, so ammonium nitrate, so ammonium is formed by the ammonium ions and then the nitrate ions. So what is the particles? So be ions. Okay, so suggest a way to modify the experiments to obtain the melting point. So just now I mentioned already, we cannot use the water because the boiling point of the water is 100 degrees Celsius only. So we can use the oil bath or sand, to replace the water bath. Okay, so oil and the sand, it will produce higher temperature compared to the water. Okay, then it can melt the ammonium nitrate. So give a reason. Okay, so just now I mentioned already. Okay, the boiling point of oil or sand is higher than the melting point of ammonium nitrate. Okay, so here if you just choose one, right? Whether you choose oil bath or sand. Okay, so in your answer you don't write both lah. You just choose one of it. Okay, now C, the electron arrangement of X2 plus is 288. Okay, the ions has 20 neutral subatomic particles in its nucleus. Okay, so since it has the charge of 2 plus, in other words, it has lost two electrons in the reaction to achieve stable octet electron arrangement. So meaning that initially it should be, for the atom of X, initially it should be 2882. Okay, this is the atom, not the ions. So draw the electron arrangement for atom X. So atom is neutral, so meaning that it has 4 shells. 4 shells. So here, okay, it asks you to draw the electron arrangement. Okay, so X is the nucleus. Okay, so first shell we have 2. We draw the shell first. Later I use the different colors to represent the electrons. there are 4 shells. 1, 2, 3. Okay, 4. Okay. So let's say we use different colors here. Okay, so first shell we have 2 electrons. 1, 2. Second shell 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Third shell 1, 2, 3, 4, 8. Okay. Then last shell is 2. Okay. So it's 2, 8, 8, 2 for the atom of X. Okay. So this is called electron arrangement. Sometimes, okay, extra information here, sometimes the question will ask you to draw atomic structure. So atomic structure actually almost the same with electron arrangement. You just draw the same as electron arrangement, but in the atomic structure you just add in the information, okay, how many protons and how many neutrons. Okay, so meaning that in your drawing, you just draw an extra line. Okay, for example, here is protons. We have 20 protons and 20 neutrons. Okay, so if the question asks you to draw the atomic structure, you just add in this information. Okay, but this one is the electron arrangement, so no need for us to give the information about the protons and the neutrons. Okay, so this one just extra information for you. So this one no need. Okay, so let's continue. Okay, write the standard representation for the element X. So just now I mentioned to you already. Protons is 20 protons and then 20 neutrons. So meaning that X, okay, so normally is AZ, right? Okay, Z is the proton number, so proton is 20. Okay, A is the nucleon number. So nucleon number is total up the proton and the neutron, so it's 40. So it's 40. Okay, so this is the standard representation for the element X. Okay, this is a proton, this is a nucleon number. Okay, question number 3. Diagram shows the apparatus to determine the empirical formula of oxide of copper. Okay, so the dry hydrogen gas is passed through the hot, because you heat it hot oxide of copper, then they will react here, then the excess hydrogen gas is burned here. Okay, let's see the result given. Okay, so let's say this is a mass. Okay, let's say we label it, label 1, 2, and 3. So let's see, mass of combustion tube with the porcelain dish, the apparatus is 53.46. Okay, then with oxide of copper, so 57.46, and then after the combustion, after the displacement reaction, so remains the copper because the hydrogen oxide is being displaced by the hydrogen already, so it's 56.66. So here we can actually do the simple calculation. Let's say if we want to find the mass of the copper will be, okay, the number 3 minus the number 1. Okay, if we want to find the mass for the oxide, will be the copper to oxide of copper, number 2 minus number 3. Okay, so later on definitely we need to calculate this. Okay, I'll show you later on. Okay, number 1, what is mean by empirical formula? So is the formula shows the simplest Okay, simplest whole number ratio. Okay, so meaning that this is the first point, simplest whole number ratio of atoms for each element in the compound. Okay, so this is the simplest explanation or definition for the empirical formula. Okay, if molecular formula, the simplest we change to actual. Okay, actual whole number ratio. Okay, write the chemical equation between the oxide of copper and the hydrogen gas. Okay, so here actually we need to calculate the empirical formula first, empirical formula first. But here, okay, actually we know that copper 2 oxide okay, react with the hydrogen gas, so it produces copper and water. So check, yeah, it is balanced, so you get 2 marks. Okay, step 1, precaution to ensure this experiment is conducted safely. So here you have to know one concept is, if the mixture of oxygen with hydrogen and then you heat it, okay, it will cause an explosion. Okay, so meaning that we cannot let this happen. Okay, so meaning that we have to get rid of the oxygen inside the combustion tube here. We have to get rid of the oxygen gas inside the combustion tube before we heat it. Okay, so how do we do this? Okay, so we can, before you heat it, pass the hydrogen, okay, into combustion tube for a few minutes, okay, before heating process. Okay, before heating. Okay, so based on the result, it determines the empirical formula for the oxide of copper metal. Okay, so like this, we normally encourage the student to draw a table. Okay, so normally we will start with elements. Okay, so there are 2 elements here. We have copper, we have oxygen. Okay, O. Okay, so first one is a mass. It's in gram. Just now I mentioned to you already is 3 minus 1. So it's copper. So it's just now is 56.66. Okay, minus 53.46. So you will get is 3.2 gram. For oxygen will be 57.46 minus 56.66. Okay, so you will get 0.8. Okay, this is a mass. Okay, after you have the mass, we can calculate the number of mole. So number of mole is used a mass over the molar mass. So is the 3.2 over the copper is 64. So use your calculator, calculate, okay, getting 0.05. Okay, so here's 0.8 divided by the molar mass for the oxygen. Oxygen is 16. A lot of students use the 32 because they assume is O2 is 32. Okay, no, because we are finding the empirical formula. We want to find the simplest ratio, so we are not using this. So we are using O is 16. So divide by 16, you get 0.05. So we get the simplest mole ratio. Okay. simplest ratio, normally we choose the smaller one, but since these are the same, so you can divide by the same number of more, so you get 1. This one also the same, get 1. So meaning that the empirical formula is Cu1O1. So empirical formula is CuO. Okay. Okay. If you have any question, you just comment at the video below here. Okay. E. Name another oxide of metal which its empirical formula can be determined using the method. So same method. So method, normally we will find one. Okay, so we can refer to the reactivity series. So we can choose lead. Okay, lead to oxide. Okay, so okay, another one. Okay, metal which is more reactive towards oxygen. Draw a label diagrams. So for the more reactive metal, okay, so we will use another apparatus to draw it, to do the experiment. So here, the question asks you to draw the diagram. So be like this. Okay, we are using the crucible. Okay, so with the lead, and normally we will use the clear pipe triangle. Don't use the wire gauze. So use the retort stand. When you draw like this, you have to use the ruler to draw. Okay, then you need to hit it. Okay. Then inside the crucible, we can put in the coil metal here. Normally is the metal X, so it's the magnesium normally. Okay, so we have to label all the apparatus. So this is crucible. Okay, this is a lead. Okay, so this is the clear pipe triangle. Question number 4. Diagram shows the elements in the periodic table represented by the letter D, E, G, L, and J. Okay, this letter is not the actual symbol. Not the actual symbol. Okay. So number 1. Okay, what is the basic principle? Basic principle used to arrange the elements in a periodic table. So now, as we know, it is according to increasing of proton number. Okay. So meaning that each one will increase by 1 protons. Okay. So element D, E, G, L are located in the same period. Okay, same period. Give a reason. Okay, if same period, okay, it has the same electron shells occupied with electrons, because they have same electron shells occupied with electrons. Okay, so meaning that when you write your answer, especially when mention about the period, okay, so you have to mention same electron shells occupied with electrons. So don't just say they have same electron shells. It's not complete. So remember that. So when D and J, okay, D and J are in the group 1 now, okay, they react with element G separately, white solid is formed. Okay, so D and J is group 1, G is group 16. Group 16, this is group 1, This is group 16. Okay, yeah. So here, write the chemical equation for the reaction between the D and a G. Okay, D and a G. So normally, okay, G here, D, let's say we use D, D is the lithium, or J is the sodium. Okay, you can choose any one of it. Oh no, G, D and a G. Okay, D, they choose D and the G. Okay, so group 1 is the metal, so normally it's a lithium. This one is the lithium. G is the oxygen, oxygen. So we know that if we want to write the equation, okay, so D is the metal, so it's the atom. So react with G. G is oxygen, so oxygen exists in the diatomic O2. So when they react, okay, D is group 1, so it's +1, the charge. Oxide is group 16, so the charge is 2 minus, because it will gain 2 electrons from here. So we interchange the numbers of the charge. 1, so the formula will be D2O, so it becomes D2O. Then we have to balance the equation. So D2, so oxygen first. Oxygen, we get O2, so here only O1, so this one times 2. So times 2. So once they times 2, D also times 2, D2 times 2, 4. So 4. Okay? Actually, you also can replace with, but no need lah. Okay, you also can replace with the lithium actually. Okay? So lithium also accepted, with produce a lithium oxide. So 2, 2. So sorry, this one is 4. Okay, 4 lithium with oxygen produce the lithium oxide. Okay, then J is more reactive than D. Okay, in group 1, when react with G. Explain this statement. So 3 marks. So group 1, okay, group 1, you will lose 1 electrons, 1 valence electrons. So meaning that if it can lose the valence electron easier, means more reactive, more reactive. So J is more reactive than D, then meaning that it can lose the electrons easier compared to D. Okay, so explain. So point number 1, okay, number 1 we can see, number 1 is the atomic size of J, okay, element J is bigger than element D. Okay, so number 2, attraction force between the nucleus and the valence electrons becomes weaker, okay, because the distance is further. Okay, so number 3, so the valence electrons is easier to be released, okay, to achieve stable octet electron arrangement. Okay, so here you mentioned the attraction force becomes weaker. It is for element J. So that's why J is more reactive because it can easily release the valence electrons compared to element D. Okay, so 3 marks. Okay, when element E react with G, a compound that cannot conduct electricity in all states is formed. Okay, so E react with G. Okay, let's see again the E and G. E is group 14. So E is 2, 4. 6. G is 2, 6. Okay. So E electron arrangement is 2, 4. G is 2, 6. Okay, both are non-metal, so they will form the covalent. Covalent compounds, so sharing the electrons. Okay, so draw the electron arrangement for the compound form. Okay, so here actually we can roughly predict. Okay, E need to another 4 electrons to achieve octet electron arrangement. G needs another 2 valence electrons to achieve stable octet electron arrangement. So here actually we can roughly draft out. E it need to share 4 electrons. G need to share 2 electrons. So we can interchange 2, 4. So 1, this is 2. So meaning that we need 1 atom of E, 2 atom of G by sharing 2 pairs of electrons. But here we need to use the double bond. Okay, share 2 pairs of electrons. So first we draw the E first. Okay, E, 2 shells, 1, okay, 2. So 2, okay, 4. 1, 2, 3, 4. Okay. So with another G, you need 2. Okay, 2, 6. Okay, so G, 2. Okay. For the sharing of shells, you have to intercept it. Okay, like this. This one also the same. Okay, so like this. They share the electrons. So for G, okay. So I use the different colors. Okay, for G is 2, 6. So first shell is 2. Okay, 2, 6. So share 2 electrons. Okay, so another 1, 2, 3, 4, 5, 6. Okay. So this one, this G also the same. Okay. So here we can see. Okay, after the sharing. Okay. So the shell number 2 will be 2, 4, 6, 8. So octet electron arrangement. So G also the same. 2, 4, 6, 8. So all of the atoms can achieve octet electron arrangement already. This is 2, 8. This one also 2, 8. This one also 2, 8. So by doing this, they will achieve octet electron arrangement. Okay, explain why the compound does not conduct electricity in all states. So if electrical conductivity, we just need to see it has freely moving ions or not. Okay, so this is the covalent compound. So it consists of neutral molecules only. Okay, there are no freely moving ions. Okay, so that's why it cannot conduct electricity. Okay. Question number 5. Table shows the information of 3 different types of acids. Okay. P is degree of ionization is high, and basicity is monoprotic. Q is diprotic. R is low degree of ionization, and then it is monoprotic. Okay. So if degree of ionization in the water is high, means it's strong acid now. This one also strong. This one is weak acid. Okay. So number 1. Okay, what is mean by acid? What is mean by acid? Okay, acid is a substance that ionize in water to produce hydrogen ions. Okay, if base or alkaline will be ionized in water, produce hydroxide ions. Okay, state the ions that enables it shows the acidic properties. So it's hydrogen ions. Okay, name the acid P and acid Q. So acid P is a strong acid, Q is a strong diprotic acid. Okay, so here you have to give the name. Name. So number 1, we can choose hydrochloric acid, or you can choose nitric acid. Okay, for diprotic acid, okay, strong acid, so just one, sulfuric. Okay. Next, okay, acid P and R, it has the same concentration. R just now is a weak acid. It is found that the pH value for P is lower than R. Okay, so explain why the pH value for both acids are different. So 3 marks. So you have to mention strong acid and weak acid. Number 1 will give the information, definition for strong acid and strong alkali. Okay, so acid P is a strong acid that ionize completely in water to produce high concentration of hydrogen ion. Okay, so lower pH. Then acid R is a weak acid, okay, that ionize partially in water to produce low concentration of hydrogen ions, so higher pH. Okay, so to get 3 marks. So here, okay, I want to explain about this. Okay, for the strong acid, you have to mention ionize completely in water, produce high concentration of hydrogen ions. For the weak acid, ionize partially in water, produce low concentration of hydrogen ions, then higher pH. Okay, so total 3 marks. So B, a student accidentally spilled the concentrated acid in the lab floor. Diagram shows the condition of the flow here. So actually these two are tiles. Here actually is the limestone filled between the gap here. Then concentrated acid drop on this limestone here. They will produce a bubbles, gas bubbles here. Okay, so actually what is happening here is the acid, whatever acid, let's say we choose the, is that mentioned any acid? No. Okay, let's say this is the concentrated hydrochloric acid. The limestone actually is the calcium carbonate, so meaning that hydrochloric acid react with the calcium carbonate. So it will forms a calcium chloride and water, and then it will produce a carbon dioxide gas. Then this carbon dioxide gas actually it forms, you will see the gas bubbles produced here. Actually it's a carbon dioxide gas. So explain the condition here, the reaction here. So 2 marks. So okay, when the limestone is the calcium carbonate now, okay, reacts with the acid, so acid actually inside there got the hydrogen ions from acid. Okay, the gas bubbles is referred to carbon dioxide gas. Okay, so explain. This is how you explain your answer. Actually, if you know the equation, then it should be no problem for you. Okay, by using some piece of limestone and the acid solution, draw apparatus to verify the gas. Okay, so to verify the gas, so here the gas we know is carbon dioxide gas, right? Okay, test tube. Okay, then inside here we have the limestone and then the acid, acid. Okay, then the gas produced, okay, we can deliver it, okay, deliver it into when you draw your diagrams in the SBP, make sure that it is you are using the rulers. Okay, so the gas is passed through the delivery tube, and then bubbles into the lime water. This is lime water. Okay, and then the stopper cannot fully immerse into the test tube here, so this is acid now. Yeah, so this is a limestone. Okay, so by doing this experiment or activity, the lime water it will turns cloudy, then it will confirm that the gas release is carbon dioxide gas. Okay, question number 6. 2 sets of experiments are carried out to investigate the factors affect the rate of reaction. Okay, so table shows the time taken to collect 40 cubic centimeter of hydrogen gas. Okay, so set 1 and set 2, let's see what is the difference. Acid used the same. Okay, zinc powder same. Okay, so here we notice that the concentration given is different. Okay, so higher concentration, shorter the time taken to collect 40 cubic centimeter of hydrogen gas. So meaning that this one higher rate, rate of reaction, this one lower rate. Okay, so this is the first thing you have to know. Okay, let's see. State another measurable changes beside volume of gas determines the rate of reaction in the experiment. Okay, now we see okay, this reaction is between the zinc and the hydrochloric acid. So we can write out the equation actually. So the equation here, okay, zinc react with hydrochloric acid, so it produces zinc chloride and the hydrogen gas. Okay, so we need to balance the equation. So here actually based on this equation, okay, actually there are four methods we can determine the rate of reaction. Okay, so we can list out. Number one, okay, normally we can determine, first one is the volume of gas release. Volume of gas release, for example, in this case is release of the hydrogen gas. So over the time we can calculate the rate of reaction. Okay, number two is the decrease in the mass of reactants. Okay, so meaning that we can actually measure the mass of the reactants for the zinc. Okay, over the time we can also determine the rate of reaction. Okay, number three, sometimes we can, in this case we cannot determine the mass of the products. We can measure the increase in the mass of product. Okay, this product will be in the solid form normally. Okay, then number four, we can also use the formation of precipitate. Okay, so there are four methods for us to determine the rate of reaction. So actually in this case we can use the first and second method. So meaning that we can use the decrease of mass of reactants or zinc powder. Okay, then over the time we can determine the rate of reaction. Okay, next, identify the factors that affect the rate of reaction. So just now we mentioned already is a concentration of hydrogen ions. Okay. So calculate the average rate of reaction for set 1 and set 2. Okay, so we calculate set one by one. Okay, set 1, the rate of reaction, okay, the volume over the time, volume is 40 cubic centimeter, over the time is, okay, 90 seconds. 90 seconds. So use your calculator, you calculate. Okay, so 0.44. Okay, you can get round to 4 decimal places. Okay, and for set 2 is also volume is 40 cubic centimeter, but the time taken is 55 seconds. So use your calculator, you get 0.7273 cubic centimeter per second. So if we compare, so this one will be higher rate of reaction. So based on your answer, compare the rate of reaction in set 1 and set 2. Okay, just now I mentioned already. Okay, set 2 has a higher rate of reaction than set 1. Okay. So explain your answer by using collision theory. Collision theory. So is a concentration of hydrogen ions. Okay, so point number 1. Okay, concentration of acid in set 2 is higher than set 1. Okay, so concentration factor, the number of hydrogen ions per unit volume is higher in set 2 okay. So frequency of collisions between so the particles here will be acid, will be hydrogen ions. So from acid and the zinc atom increases. Okay, number 4, the frequency of effective collisions between, here you can mention the particles okay, hydrogen ions and zinc atom increases. So it has higher rate of reaction in set 2. Okay, so 4 marks, 4 points. Okay, so sketch a graph of volume of hydrogen gas against time. Okay, so volume of gas against time. So the one mentioned first is the y, then against time is the x. So here we have y axis, so volume of hydrogen gas, unit, don't forget, cubic centimeter. Okay, time is seconds. Okay, so from here actually we can draft the graph. Okay, so roughly we have 2 times, right? Okay, one is 55, another one is 90. Okay, so roughly, okay, we'll put here 55, another one is 90. Okay, so here, okay, for set 1, okay, roughly is use the 90. Okay, so set 1 takes longer time to reach 40. Okay, let's say here is 40 now. Okay, so this is for set 1. Okay, then set 2 is takes shorter time. Okay, so meaning that let's say shorter time to get 40, so meaning that steeper gradient. Okay, so this is for set 2. Okay, okay, so this is for set 1. Okay, so this is how do we sketch the graph. Graph means it's just if sketch the graph, no need to use the graph paper, we just sketch it, plot in all the important information like this, then you get 2 marks. So that's all for the section A in the SBP trial paper. So if you have any question, you can write at the comment below. Okay, thanks for watching.